Hello students, welcome back to my channel Pharmaceutical Concepts. Today I am here with another topic, that is alkyl halides from semester 2 POC with methods of preparation of alkyl halides. As you can see here, alkyl halides are prepared from alcohols, from alkanes, from alkenes, okay, and from alkynes also. Very important method of preparation from alcohol, because from alcohol again there are many reagents using which we can prepare the alkyl halides. As alcohols can be converted to alkyl halides. Okay, this is alkyl and this is halide, right? So fluorine, chlorine, bromine, iodine, we are talking about all of these. So now moving to the specific methods. From alcohol, again, as I told you earlier, there are various reagents using which we can prepare the alkyl halides. So let us first jot down the various methods. Okay, first let us understand PX3, for example, PCl3, PBr3, PI3, they can be converted into alkyl halide. Even using PCl5, we can prepare RCl, very specific. Since it is phosphorus pentachloride, here I'll get the alkyl chlorides. Next, very important again, is SOCl2, which is nothing but thionyl chloride. Again, very specific, alkyl halide can be prepared here. Then we have HX, okay, hydrogen halide, which will give the alkyl halide. So again here, HX means what? I can use yes, I can use the HCl, HBr and HI also. Okay, let us understand each method quickly. So I have this alcohol with me and this PX3, that is PCl3 or PBr3 or PI3. I can get from the red phosphorus, comma X2. So it could be Cl2, it could be Br2, it could be I2 also. And it is giving me Rx. So how to remember this? To remember this, let me first write this alcohol like this, and then PX3, this PX3, right? Okay, PX3 I can write in this way, PX3. Okay, so from here, this this part leaves as the byproduct. What is this part? This is H3PO3. Okay, so in this way you can remember. And what I'm getting here, see, RX. I'm getting RX, RX, and one molecule of this byproduct, 3 RX from 3 moles of alcohol. So this is how you can remember this. I hope this is clear. Few important points to remember about the first method, the PX3 with which the alcohol was reacting. This PX3 could be PCl3, PBr3 and PI3, right? So among these three, this PCl3, no, this is very much stable. But these two, these are less stable, and therefore we need to prepare them freshly. And hence the method of preparation has to be written always on the arrow. Okay, so arrow is nothing but method of preparation of this either PBr3 or PI3. So for PBr3, what we can write? For PBr3 we can write P plus Br2. For PI3, what can be written on the arrow? Okay, so if you see this condition on the arrow, or this condition on the arrow, that means it is nothing but PbR3 or Pi3. Alcohol reacting with phosphorus pentachloride giving me alkyl chloride. Okay, ROH, I can write in this way. And how I should write this PCl5 now? See, PCl3, Cl, Cl. Okay, see here px5 also you can remember always. So here I can write px3 x x. Okay, let us first show you for the specific PCl5. This is how it will break. This is product RCl, this is byproduct POCl3, and third byproduct HCl. I hope this is clear. This is how you have to remember this. RCl, POCl3 and HCl. Okay, simple. Reaction of alcohol with phosphorus pentachloride. Now moving on to third method. Third method, which is one of the best methods to prepare the alkyl halide from alcohol. Okay, and that is reacting ROH with SOCl2. What is SOCl2? SOCl2 is thionyl chloride. Okay, so how to remember the reaction? I am preparing here RCl, right? So how to remember what would be the byproducts? So for that, let me write it in this way, the alcohol part and then SOCl2. So let me break it in this manner so that I'll remember the byproducts. So it is, see what is this? The second part is SO2, which is sulfur dioxide, gaseous. So I'll show the gaseous byproduct by this arrow. And the third byproduct is this HCl. Again, HCl is gaseous, so I can show this arrow. So this method is also called as Darzan's method. And why this is best method? Because the byproducts which are obtained, these are gaseous byproducts. So the gaseous byproducts will leave the main product, and main product in pure form can be obtained easily. Therefore, this is one of the best method. So these three methods we have seen so far. First method of preparation from alcohol is using PX3. Second method using PCl5. Third, which is one of the best methods, with thionyl chloride. And fourth method which we are seeing now, that is with HX. Before we move further, we have to remember that these first three methods are without any rearrangement, whereas the fourth method, this involves the preparation of carbocation, and whenever this carbocation is there, there are chances of rearrangement. So what is this that we are seeing here? So from this slide, what are we remembering? We are remembering that this fourth method, which is with HX, that is HCl, HBr, HI, this method involves the formation of carbocation, and whenever I see carbocation, there is possibility of rearrangement. ROH, HX in presence of anhydrous zinc chloride, okay, making RX. If you have observed on the arrow, HX means it could be HCl, it could be HBr, it could be HI. HF is not there. Why? Because HF is unreactive and hence it is not used. And before we move further, please note down the order of reactivity of alcohol with HX is tertiary, secondary, and primary. That means what? Tertiary alcohols react faster with HX, and Also note down the order of reactivity of HX. That is, HX means what? It could be HI, HBr, and HCl. So among these three, which is more reactive? So of course, we know that HI is more reactive than HBr and HBr is more reactive than HCl. This is because of the size difference. See here, fluorine, chlorine, bromine, iodine. So iodine, its size is much more as compared to these three. So size difference between these two, more the size difference, more will be the bond dissociation, more easily the bond will be dissociated. That means less bond dissociation energy, and therefore breaking of this bond is easier than breaking of this, and this is most difficult among these three. Okay, so let us learn more about this particular reaction. So if I give you this example, CH3 CH2 OH plus HCl, okay, and anhydrous zinc chloride here. So can you make this CH3 CH2Cl? Just the substitution, this OH is going and Cl is coming here at this place, right? And what is leaving? Water is leaving as a byproduct. So this chloroethane which is formed, that is the main product. This was the example of primary alcohol. Okay, so primary alcohols are less reactive and therefore we need this catalyst, that is anhydrous zinc chloride. Even if you have this secondary alcohol like propane to all, okay, that is isopropyl alcohol, if it is reacting with HCl, then also you will need this catalyst, that is anhydrous zinc chloride, okay, which is making this 2-chloropropane, right? So I'm just replacing the OH with Cl and water is leaving as the byproduct here. So what is its name? 1, 2, 3. So can I say that it is 2-chloro, 1, 2, 3. So 2-chloropropane, right? But see, this is secondary, this was primary. So if I take one more example of the tertiary alcohol, so CH3, CH3, CH3. Let us take the simple example of this tertiary alcohol which is reacting with HCl. So on the arrow now I don't require this catalyst. I don't require to write this name of the catalyst on the arrow and to use this for the reaction. Why? Because this is tertiary alcohol and tertiary alcohols are highly reactive. Okay, they are highly reactive. Therefore, they don't need anything on the arrow. So just the substitution reaction CH3, CH3, CH3. If I number it, 1, 2, 3, third carbon, okay, plus water. So this is 2-chloro, 2-methyl propane. That is tertiary butyl chloride is the main product here. Now I will show you how the carbocation is formed here and how the rearrangements are possible in this particular type of reaction. This HBr which is being used in this particular reaction is less stable, okay, and therefore we have to prepare this reagent freshly. So how to prepare this HBr? Sodium bromide plus sulfuric acid, which is when heated forms HBr, okay, and this condition, this can be written on the arrow. Which arrow? This ROH NaBr plus H2SO4. If this is written on the arrow, you have to understand that they are trying to tell us that HBr is the reagent used and thus RBr, alkyl bromide, would be the product which is being formed. So if instead of HBr, if this is given on the arrow, don't get confused. So prepare the correct product of alkyl halide. If it is HI, again, so HI can be prepared from NaI plus H3PO4. Okay, that is making HI. So this NaI plus H3PO4 could be written on the arrow. Okay, so if this is given on the arrow, okay, then don't get confused. What is this reagent all about? Okay, you understand this reagent, that this is nothing but HI, and you prepare the respective alkyl halide. That is ROH, which is reacting with this HX in presence of anhydrous zinc chloride. So zinc chloride is not doing anything, it is just the catalyst, okay, increasing the rate of reaction. So how do I write this HX? I write this HX as H plus X minus, right? H plus X minus. This alcohol, oxygen, has lone pair of electron on it, okay? Let me show this on this side. This H plus can be taken up by this lone pair, and we call this step as protonation. So how this will look like? This is the original hydrogen and this is the new hydrogen taken up, right? So now what will happen here? See, oxygen having lone pair on it is normal. Okay, this is the normal oxygen. But now this lone pair has been involved in this bond formation, right? So that means there is deficiency of electron on the oxygen now, and that deficiency I'm showing by this positive charge. Okay, again, this is not the stable compound. So what will happen? This bond will try to give its electron to this oxygen, okay, to fulfill this deficiency. So this R is alone now. This R, see, has this electron with it, and this another electron was with oxygen, and this bond was formed. Now these both the electrons they have moved here to the oxygen so that it is leaving as water. So now there is deficiency of electron on this R, and that deficiency I am showing here by putting this positive charge. And this is the carbocation which I was talking about. So wherever this term carbocation is there, wherever you form this carbocation, what you have to remember? You have to remember rearrange if possible. Rearrange if possible. Okay, wherever you see this carbocation. So now what will happen? Now this X minus will come in the picture. So now what will happen? This R plus and X minus, they will react and they will form this product, that is RX, alkyl halide. I hope this is clear. I'm going to show you this with more examples so that the mechanism and the rearrangement will be understood clearly. Now, the rearrangement which I was talking about regarding this carbocation, wherever you see this word carbocation, rearrange if possible, right? So this rearrangement could be by three ways: by hydride shift, it could be by methyl shift, and third, it could be by ring expansion. So let us take this example of the simple alcohol which is reacting with this HCl. Okay, what will be the product? Can you guess the product? You can guess the product, and by the time, let us try to understand the mechanism. So HCl is nothing but H plus Cl minus. I can see this oxygen here. So lone pair of electron on the oxygen. Okay, it is attacking this H plus. So now what will happen? This O, this is original H, this is new H taken up, and positive charge on the oxygen showing the deficiency. And now this bond will give both the electrons to the oxygen so that water is released here. So now how this structure will look like? See, this part is as it is, this is as it is, but this bond is broken, no? See, this bond is gone now because these both the electrons from the bond are gone. That means this carbon now gets the positive charge. Okay, this is CH3 CH3, CH, CH2OH. So this is nothing but CH2 plus. This is CH, CH3 and CH3. So this is the carbocation formed. Now you can see here, this is the primary carbocation which is formed here. So whenever I talk about carbocations, the tertiary carbocation is more reactive than or more stable than the secondary, and secondary is more stable than the primary carbocation. This is the carbocation stability. Okay. So whatever carbocation I have got here, that can I rearrange it in the more stable carbocation? Based on that, we can do the rearrangement. So here, if you can see, I can definitely take up these 2 electrons from this bond, so that, see, this CH3 is as such, this CH3 is as such, this C, okay, and this hydrogen I am shifting here, so that this becomes CH3. And now the deficiency of electron, because these 2 electrons have gone here, no? So deficiency of electron now I'm showing on this carbon. So this is now becoming the tertiary carbocation, and I know that tertiary carbocation is more stable. So that this is called as the rearrangement for the more stable carbocation formation. Okay, and now this Cl minus will come into the picture. Now what will happen? Chlorine. Okay, so this is the CH3, CH3 and CH3, and this is the product which is formed here. I hope the carbocation rearrangement, this term is clear to you now. Just now we have seen the conversion of alcohol to alkyl halide with HX in presence of anhydrous zinc chloride. Okay, if it is primary and secondary alcohol, then this catalyst is required. Now the alkyl halide which is formed here, this alkyl halide is turbid solution. Okay, the alkyl halide which we get here, that is the turbid solution which we get. And this turbidity now depends on the carbocation. Depends on carbocation. So if it is primary carbocation, whether it is secondary carbocation, and whether it is tertiary carbocation, that decides the appearance of turbidity. For example, if the primary carbocation is formed and on that primary carbocation the X is going to attach, okay, then the turbidity appears after long time. Okay, so you can say no turbidity or appearance of turbidity after long time. If it is secondary carbocation, the turbidity appear in minutes. That means it takes little time, but it appears in minutes. Here it takes long time to appear. Here it appears in minutes. And if it is tertiary carbocation, the turbidity appears immediately. Okay. So this test is also called as Lucas test. That is conversion of ROH, that is alcohol, to alkyl halide with the help of hydrogen halide. Okay, we get H plus from HCl, right? So this is RCH2OH2 plus RCH2 plus. I hope you have understood this mechanism which I have explained on the earlier slide. So this is primary carbocation. No, this is primary carbocation which is formed here. So this solution, for this solution, turbidity appears in long time turbidity. In the same way, if I have the secondary alcohol over here, okay, What will be the mechanism? OH twice, positive charge on the oxygen, your secondary carbocation which is there, and I'm getting here the secondary alkyl halide, right? So secondary carbocation turbidity appears in minutes for this solution. If I have the tertiary alcohol reacting with H plus of HCl, this R3C plus, by removing the water, Cl minus from HCl, and it will give me R3CCl. So this solution which is obtained from this tertiary carbocation, for this the turbidity appears immediately. But there is one more point about this Lucas test. If there is resonance stabilization, if there is resonance stabilization means what? For example, I have this particular alcohol. Okay, so what will happen to this? H plus is here. This will be attacked. So I have this OH2 positive charge. This bond is giving both the electrons, so that water is left. And I have this positive charge here. So this is primary carbocation, right? But what is happening? Because of this pi bond over here, the pi electrons, the charge can be shifted, and thus I say that this is secondary carbocation because of the resonance stabilization. Means the primary carbocation got converted to more stable secondary carbocation, and these secondary carbocations show turbidity in minutes. Okay, so in contrast to this, if I would have had this particular compound, okay, then my carbocation would be this. Here there is no resonance to stabilize this particular carbocation. So for this carbocation, from this carbocation, whatever compound of the alkyl halide I am getting, for that the turbidity appears in long time.